Hello all, welcome again to Computer Graphics, a practical approach channel. If you didn't watch video on curves, a basic fundamental, please pause this video and first watch that video. Link of that video given in description. In that video, we discuss about curves, types of curve and curve generation techniques. And at the last, we discuss the important properties of curves. Now, in this video, we discuss about Bezier curves. A Bezier curve is a type of spline, a curve defined by a control points. So, to define the Bezier curve, we require control points. Bezier curve is discovered by the French engineer Bezier. These curves can be generated under the control of the points. Approximate the tangent by using the control points are used to generate the curve. The Bezier curve can be represented mathematically as summation I equal to 1 to n xi bi raised to n of a, where xi, the set of points, bi raised to n of a represent Berenstein polynomials, where n, the polynomial degree, I, the index, a, the variables. As I discussed, a Bezier curve is defined by a control points. The number of control points varies per type of Bezier curve. So there are different types of Bezier curve, and according to that type, the number of control point is varies. So first type of Bezier curve is a simple Bezier curve, better known as straight line, and has two control point P0 and P1. The distance between P0 and P1 determines how long the curve moves into direction P1. Next one is a quadratic Bezier curve, has three control points P0, P1 and P2. The curve starts at P0 and going towards P2 and going towards P2 from the direction of P1. Usually, it will not pass through P1. These points are only there to provide direction information. Next one is a cubic Bezier curve, has four control points P0, P1, P2 and P3. Cubic curves are commonly used in graphics because curves of lower order commonly have too little flexibility, while curves of high order are usually considered unnecessarily complex and make it easy to introduce undesired wiggles. To join multiple curves into one curve smoothly, we need to specify the position and their tangent vector of both ends, that is the continuity requirements. 4 points P0, P1, P2 and P3 in the plane or in three-dimensional space define a cubic Bezier curve. The curve starts at P0, going towards P1 and arrives at P3 coming from the direction of P2. Usually it will not pass through P1 or P2. These points are only there to provide direction information. The distance between P0 and P1 determines how long the curves move into direction P2 before turning towards the P3. So all this shown in this figure. An important point to be noted about the cubic Bezier curve is a cubic Bezier curve indirectly specifies the endpoint's tangent vector by specifying two intermediate points that are not on the curve. Next, we are discussing Bezier curves' different properties. So, properties of Bezier curves. Bezier curves always passes through the first and last control points. That is, curve has same endpoints as the guiding polygons. The degree of the polynomial defining the curve segment is 1 less than the number of defining polygon points. Therefore, for 4 control points, the degree of polynomial is 3, that is cubic polynomial. So, for the Bezier curve, the polynomial degree is depend upon control points. If we require polynomial degree as 2, then we have to take 3 control points. If we require degree as a 4, then we have to take 5 control points, and so on. The curve generally follows the shape of the defining polygon. The direction of the tangent vector at the end points is the same as that of the vector determined by first and last segments. They are contained in the convex hull of their defining control points. The convex hull property for Bezier curve ensures that the polynomial smoothly follows the control points. Bezier curve exhibit global control means moving a control point alters the shape of the whole curve. It means that if we change the position of any points from the curve, then the shape of the curve will be changed. So the Bezier curve is basically provide us or exhibit a global control, means moving a control point alters the shape of the whole curve. So this is all about Bezier curve. Thank you for watching this video. Before leaving, like this video, subscribe the channel. Thank you. Good day.